Good evening, students. Warm welcome to you. In the coordination compound, students, what we have discussed up to now. What are coordination compounds? What is the difference between coordination compounds and a double salt, students? What is the difference? Fast 30 seconds.
Sir, what is the difference between double salt and okay? Double salts are those salts which are formed by the addition of two simple salts, and complex salts are those salts which, when they are dissolved in water, they dissociate in water and behave as one identity. That means the species in the bracket do not dissociate completely.
Now you see that you know the answer, but since the question was asked in a just a flash of second, and it needs time to see what answer be written, students. Why do I repeat all these things? Because when a question is given, it is carrying only 1 mark, students. You're not supposed to write things which are not required. How they are formed has not been asked, so don't go into those details, students. We told you one simple trick, a simple thing, that double salts will dissociate completely into ions. And coordination compounds, what happens, students? They are not completely ionized. They are not completely ionized. And the you have seen when the complex ion does not dissociate. The complex ion does not dissociate into the solution. That's all. Okay. Then we have discussed with you, students, that the discovery of the coordination compound was done by Werner. Okay? You agree with that? He was awarded Nobel Prize in chemistry also. Now, what in one line is the Werner's theory of coordination compound? Students, what is Werner's theory of coordination compound?
Sir, Werner's theory of coordination compound says that there are in a coordination compound there are two types of valencies, a primary valency and a secondary valency. The
Yes.
primary valency is the ionizable valency, which is outside the coordination sphere, and the secondary valency is the non-ionizable valency. It is the coordination number.
Okay, that good answer. There could be better than this also, because the most important point was that there are not one type of valency, there are two types of valencies. One, you talked of primary and secondary. That is absolutely right, student. Primary valency is the oxidation state of the metal ion, and secondary valency is the
Coordination number.
coordination number, or those ligands which are attached to the metal ion. Non-ionizable, that also is correct. Okay. After this, students, we have given you how to name these coordination compounds,
Yes, sir.
because IUPAC scheme has been given to write the formula of the coordination compounds. We have discussed how to find the oxidation state of the metal ion, students.
Yes, sir.
All important point. Then we have discussed the isomerism also, students. And then we have discussed various types of geometrical isomers and structural isomers also, students. Can you tell me which structural isomers were discussed, students, in 30 seconds? Structural
Uh,
isomers. Which
which
were those? Which were those, students?
which structural isomers were ionization isomers,
Okay.
solvate isomers.
Okay.
Then we had linkage isomers and coordination isomers.
What is a linkage isomer? Fast, student. 1 second only. 30
Linkage
seconds.
isomers are the
Formed by.
they were ambident ligands. They are
Okay.
formed by
Okay.
the
Okay.
ambident
Okay.
ligand.
When more than one atom can bond with the central metal ion, but at a time only one bonds. Okay. Okay, student. Next. What is a hydrate isomer or solvate isomer, students?
Sir, hydrate or solvate isomers, there are difference in the number of water molecules inside and outside the coordination sphere.
Okay, very good answer. Next question. What are the coordination isomers, students?
Coordination isomers are they are compounds containing anionic and cationic parts, and there is
Complexes.
interchange of ligands between the anionic and the cationic entities of different metal atoms.
Okay. All right, students. So, what we have seen, students, coordination, linkage, ionization. What is the ionization isomer, students?
Sir, ionization isomers are those isomers in which the ions are different outside and inside. They can be exchanged.
Ex-
Counter
The
ion itself can
okay.
become a ligand and displace a
The
ligand.
ions of the ligand can become the counter ions,
Counter ion.
or counter ion can become a ligand, students. All right. So it is important, students. You have seen that what is a mer and Fec isomer, student? Mer and Fec isomer, student. We discussed that in geometrical isomers.
Yes, sir.
Which type of ligands were showing, student, that?
Uh, they were mainly octahedral complexes, which showed
And Ma3B3 type?
Ma3. Yes, sir. Ma3b3.
Ma3B3 type, student?
Yes, sir.
Can you give me example of that? COCl3, NH3, three thrice.
S-
Such a
Uh,
complex was formed, student. They were exhibiting mer and facial. Could you draw it?
facial
Okay,
also.
I'm not asking you to show me. I mean, this is important question for the paper,
Yes,
students.
sir.
You know already. So, students, we have discussed various type of isomerism. One question is coming on isomerism, optical isomer. Also, one question will be there, student, just to refresh and recap the story which we are talking with you. Almost we give a good revision of this course which we have done, students. So we know, student, how to write the formula, how to write the IUPAC naming of these coordination compound, students.
Yes, sir.
And then after this, student, what was done was, can you give me an example of a hexadentate ligand?
EDTA.
Only EDTA you will write. EDTA is not the correct answer because there is something more in it. Why did I ask this question? All the students will say that. EDTA known to all the students. What is important, student? Why do I do these question
So number
answer?
of donor sites.
What is the
Uh,
formula of EDT, student? CH2
CH2
CH2 N
N.
N. If I put H2 it
N.
becomes ethylene diamine, student.
Yes, sir.
And if I put
CH2
CH2
CH2 COO minus.
COOH CH2 COH CH2 COH, this is EDTA. How many ligands it has? Only two. Now, what I do then? I say EDTA 4 minus,
4 minus.
students.
4 minus. Yes, sir.
This is the point, student. That's why I asked this question. Now, what is the story? CH2, CH2N,
C N
CH2,
N
CO minus,
minus.
CH2, CO minus, students. N, CH2, CO minus, students.
Okay.
See the difference?
Yes,
It
sir.
will be written like 4 minus 1, students. All right. Can you give me the example of a chelate ligand, student?
Uh, Sir, it will be uh,
What is a chelate ligand, students?
chelate ligand is a type of ligand which uses two or more sites for bonding, and
No,
this
donor
causes
atoms. Donor atoms.
cyclization.
So they can form cyclic rings with the
Yes,
metal
sir.
ion. Then you
CH2.
already know what is the problem. So many, you know, E and you know, oxalato, you know.
Yeah.
And EDT, I have already written EDT 4 minus. So students, you already know that they can form cyclic rings. So are the chelate formation coordination compounds more stable? Chelate coordination compounds, student, more stable?
Yes, sir.
Why?
Sir, because they can form cyclic rings.
Yes, then what happens? We will explain more about this delta H, delta H, delta S, students. uh, we can explain it thermodynamic stability also. What happens, students, in this case there will be increase in entropy, and students, there will be the Gibbs free energy will decrease and the compound will become more stable. Therefore, these are very important and strong biological applications. Very important, which we'll see in the applications part, is also important for the coordination compounds. They have a biological importance, students. You know that chlorophyll contains which metal is present in the chlorophyll, which is forming the coordination compound. Chlorophyll is a coordination compound,
Magnesium.
students, of which
Magnesium.
element?
Magnesium.
Magnesium. And hemoglobin is a coordination compound of which
Iron.
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 So many things are there in B12 also. There is some cobalt. So you can see that the coordination compounds are very essential, important, have a wide applications. So even in the extraction and metallurgy, they will be used a lot of, students. After this, we talked about the bonding in this, and after the Werner theory, the next theory which was given was VBT, students, valence bond theory, where we talked of hybrid orbitals of the metal ion, and what happens, the ligand acts as electron donor, students, and we could explain and predict the what we could predict by VBT, students. VBT was successful in doing what? It could give us the what?
It could hybridization.
One, hybridization means it could tell you the directional or the shape geometry of these coordination
Shape
compounds.
also.
One second, what it explained, student. What else was done by the VBT? Magnetic behavior. How much paramagnetic character is there?
Okay, yes, sir.
You could
Magnetic
explain
behavior.
them, but it could not give the color and other type of things which were. Then we came to the what we came to the crystal
Crystal
field theory,
field theory.
students.
Yes, sir.
Crystal field theory. Then what is the most important part of the crystal field theory? That we were able to explain the color.
Color.
Color we could explain in the crystal field theory. The color of the gemstone is also. What is the reason of the color of the coordination compound, students? Fast, 30 seconds. Color is due to
Due to the electron transition between the split d orbital, dd
DD
transition.
transition. That is what you call DD transition in one word. If a one word answer is required, it is a DD transition. In objective type, they may be giving four choices. If this choice is there, that is more than enough, students. So we know how to exhibit the color of the transition, and as the ligands will change, what is crystal field splitting energy, student? CFE. What is crystal field splitting energy, students?
This crystal field splitting energy is the energy gap between the T2g and EG orbitals
Okay, students, thank you very much. In
in
octahedral complex,
octahedral
I have shown
complex.
you, student. This was our T2G. This is my EG. Which complex is this? Octahedral.
Octahedral.
That's what our delta octahedral, students. Delta octahedral. Okay, this we could understand. This we could understand. Thank you very much for answering the question, students. I know that a lot of brain exercise is done with me, students. I always do that because I warm up the students. I see the last session is in few students were completely washed out. I found that they forgot every damn thing. So I don't know what they're doing. So because they didn't revise, repeat the things, and they listen, but maybe they are not paying full attention, student. That is absolutely essential part of our learning. Here I am just to decode the entire science and chemistry books at the same time. I want to deliver the best of the best to the students, so that in my absence, in the absence of any teacher, they can do the thing themselves. Students, you will need coaches at different areas of our different levels, students, because there are levels of every game. I mean, those who are playing inter school, then national games, then international game, you have seen there are different level of the coaches which are provided to the students. So they seek help of various government agencies, etc. also. Now the interesting thing is what happens, student? What happens? There was a question that aqueous solution of students copper sulfate is blue in color. Is
Blue
blue
in
in
color.
color. ठीक है? Okay. Further, he says it gives a green precipitate student, ठीक है, with aqueous potassium fluoride, aqueous KAF student. And second, what happens student, it gives a bright green solution, bright green solution student with KCl, ठीक है. Explain students. You are provided with experimental results of this. You are asked to explain it, student. What is your answer, student? You have 1 minute to think and answer the question, students. I hope you have been able to do a lot of things, student. More lot of things have been answered. How much we learned, we wanted to see. How much we are learning is important. The lectures are not going to be just for the sake of giving lecture. They are meant to teach and learn. How much we learn from these students? Okay. All right, students. Okay. Okay, students. What has happened, student? First of all, what is the reason of the blue color of copper sulfate, student? First question would be that why it should be blue in color. Every question is a question.
uh, ec- copper sulfate is represented as Cu, then H2O whole 4
Is
SO4.
written copper sulfate aqueous. ठीक है. In water, you have H2O molecule, student.
Yes,
Water.
sir.
So what happens then? CuH2O4
H2O
2.
whole 4
This is the
and
copper
SO4.
chemicals.
Yes, sir. So
Therefore, this is blue in color.
blue in color.
Blue in color, student. Okay, what happened then?
Then when Kf is added to it, a new complex entity would be formed. It will be, since water is a weak ligand than F minus, so it will be displaced and it will form CuF4 whole 2 plus.
What will be the charge on that?
CuF4 charge will be 2 plus.
Then what is the oxidation state of copper if it is 2 plus? What is the charge, students?
The charge will be minus 4 plus 6.
Charge will be how much? Can the copper be plus 6, students?
प्लस
Have you
तो हो ही नहीं
seen plus
सकता.
6 state of copper anywhere in the book till
प्लस
now?
6 तो हो ही नहीं सकता तो.
That is the reason. See the brain exercise. Why did I give this question, student? I knew where the mistake will come. I am not. uh, this will be 2 minus, students. This is four. This water is neutral, and there are 4 F minus, student. One fluorine is 1 minus 1 charge, students.
Okay.
So see, this is a story. Students will do the mistake here. Because of this formation, the color is, you see what color you are getting, green precipitate.
Green.
If you write 2 plus, it is out. Your answer is then 0. Got my point?
Yes, sir. Yes,
They
sir.
will give 4 choices, students, to confuse the student in the exam. They will give right like so many formulas. And in the other case, what will happen? Student, you will get Cu, Cl4, 2 minus. So the
Yes, sir.
water is
Which
being
is
displaced by these ligand, students. And this is what color? Bright.
bright green.
Okay, that is the point, student. This was the reason this question has been put up by me, students. So, further question was, student, that what happened to a coordination. What is the coordination formed when excess of KCN is added to solution of copper sulfate? You have copper sulfate, student, and you add to this KCN. And what was the result of this? That when H2, when this complex is formed, student, H2S gas was passed through this complex, ठीक है?
Yes, sir.
And no precipitate of students CUS was formed. No precipitate of CUS was obtained. How will you explain this, students?
Okay.
What is the complex which is formed here, students? First you had
Sir, here will be
Cu2 plus
CuCN whole 4 2 minus.
CuCN
Whole 4 2 minus.
2 minus. So once this complex is formed, student, then copper 2 plus ions are not available, and therefore there will be no precipitate by the
No
sulfide ions.
precipitate because
So
cyanide
copper
ion
2
is
ions
strong
is
free
not
element.
available. They are not free, and hence no precipitate can be produced. So you can see that question can be put in many ways. And the only way is if we are able to do more and more question, it helps us a lot, students. The mind works, and then we can do them, and variety of questions can be given to the students. They will be able to answer the question, students. Okay, thank you very much, students, for interacting and trying your best to answer the questions. The question answer session for the time being is over, and let us see the next part of the crystal field splitting, students. What we discussed in the last time was the crystal field splitting of octahedral complexes. What we discussed, student? Crystal
Yes,
field
sir.
splitting of octahedral coordination
Complex.
entities. Now, if I talk of tetrahedral, student, tetrahedral coordination entities, students, coordination entities, what will happen? Now, if the ligands in tetrahedral, how many ligands will be coming, student? Four ligands.
4.
And they are oriented at which axis, students? Which axis they are, students? Now if you have x y z axis, then you know in tetrahedral what is the geometry of this. If I have a metal, and in tetrahedral, what type of geometry you are having? This is your tetrahedral. How much is the bond angle, student? 109.5
109.5.
degree. This is the bond angle of the tetrahedral. So students, if we consider a cube and metal ion inside the center of the cube, are these ligands coming from x, y, or z directions? They are not at x, y, or z, students, because the x, y, or z directions, where are those? X, y, and z. X, Y, Z. So students, these are the X, Y, Z. They are where at 90 degree to each other.
Yes, sir.
Now the ligands are not coming from X, Y, or Z. And the two d orbitals which are located to the X, Y, and Z, what are those? X, Y, Z. You have dx square, y
dx
square,
square
and dz
minus
square. These
dz
are
square.
located in along XY
along X, Y,
and Z
and
axis.
Z.
So here they are not coming in face to face directly with the ligands. Therefore, these two orbital students, they will have less repulsive interactions. They will have less repulsion
Okay.
with the point negative charges you are saying of the ligands. There are electrons present in the d orbital charges of the ligands. But the ones which we told you, dxy, dyz, and dxz, their orbital electron density is in between these axes. So
Yes, sir.
they will experience a field greater field of the ligand student. Which one? The three which we said. What are the three? dxy,
DYZ
dxz, and dyz.
and DYZ.
dxi, this dyz students. Okay. They are going to experience student greater repulsion. So here is the repulsion student which is going to be experienced by this. Therefore, their energy will be raised, student. This energy will be raised. Okay? And here what happens from the base center, if I say there is a base center, we told you 0 point, there will be lowering of the energy here. Okay? So the splitting takes place, but the order of splitting is reversed as it was in reverse of the octahedral splitting. Octahedral splitting. Is it right or wrong, students? Tell me, is it correct or wrong? So these are the 5d orbitals. And what happened as the ligands approach till the field is symmetric field, as they are coming near the energy is rising, student. So there is a increase in energy. This is your base center or the 0 point, student. And what happens when they are coming from the
Yes.
ligands are located tetrahedrally to the central metal ion, students? The 5d orbitals will get split up into, the 3 will go to higher energy from this point which we are saying 0, and the 2 will come to the lower point. So what we call, student, this type of splitting, this is a splitting of the tetrahedral splitting, and here we are calling this splitting as delta T, student. There I call delta O. Delta T means tetrahedral splitting. This is my tetrahedral splitting, students. Okay? And then the order is
Okay.
reversed. The splitting order is reversed in the case of
Okay.
tetrahedral. You can see it, students. And if I consider this as a 0 point, student, then how much
Yes.
is this? Plus 0.40 delta T, and from this is how much, student? This value will be how much? Minus 0.60 delta T, students. Delta T means tetrahedral. So we are saying one is a tetrahedral splitting. And further, students, in this case, only 4 ligands are approaching. Only 4 ligands are approaching from the tetrahedral side,
9.60.
and the splitting energy will be less than the octahedral split. The delta T is very much smaller as compared to delta O. So the splitting of the tetrahedral is lower than the splitting in the case of octahedral. Moreover, as you can see, they are located in the tetrahedral 109.5 degree. The interaction is less. The number of ligands is less. Therefore, The d orbital splitting is inverted and smaller as compared to octahedral splitting for the same metal. Clear? For the same metal, students, such questions are asked. Actually, they will be asked. For the same metal, student, the tetrahedral splitting delta Te is less than delta O. They ask the reason for that. Only four ligands are approaching, and they are approaching from the 109 tetrahedral geometry. So their interaction is less, number of ligands is less. What will happen? The repulsive interactions are lower. Therefore, this value is smaller.
Okay.
So what will be the result of that, student, then? What will be the result of that? If the energy is less, and what is the result of that? It has been found delta T is equal to 4 by 9 of delta O. Further, students, important point, when this splitting energy is less, what will happen? The splitting energy is less, the pairing energy is more, then what will the electrons do? What will the electrons do? They will, rather than pairing, they will go to the higher orbital. So electron
Higher
filling,
orbital.
when electrons will be filled, students, electrons will be filled according to which rules you are filling? Same FBO
Of Bohr principle,
and Hunt's,
Pauli's exclusion principle, and Hund's rule of maximum multiplicity.
FBO, Hunt's, and which is the Pauli's.
Pauli's exclusion principle.
Now, when the filling will take place, what happens? They will, rather than pairing, student, they will go to from Eg to the from Et. This is tetrahedral. E to the triplet. So the result of this is what, students? That the complexes which you will get, there is not going to be pairing. Okay? So you will get high spin complexes. In the case of tetrahedral, what type of complexes you will get, student? Lower or high spin?
High
What type
spin.
of complexes you are getting in the case of tetrahedral?
High spin.
High spin. So you are getting, student, high spin complexes in the case of tetrahedral complexes. So very rare cases are there. Rarely you will observe low spin complexes. And the energy gap is less, therefore pairing is not taking place, electrons go and jump, and not much has been given in the course for tetrahedral complexes. Only few points which we told you are important, that the energy gap is less, so the spin configurations will be high spin, not the low spin. Not low spin are not observed mostly. Why they are not observed? Because the splitting energy is less. So there is nothing much about this. Rest is the same thing we can see. Because the splitting level is less, therefore it is not that big, and there are less questions in that.
Okay.
Up to now, students, we are aware of what we are aware, what we have learned up to now. Tell me. You have learned important things, the splitting of the d orbitals by the crystal field theory. And that there are limitations of the crystal field theory also, students, because it is also based on the assumption of point charges, and you know that that is not absolutely right, and it gives no idea, because some covalent bonding is there, it is not telling anything about that, students. And also the spectrochemical series which it has given, which is observed experimentally, it fails to explain why the halide ions have very low values, whereas halide ions have a strong negative charge. So instead of having a higher on the ligand field, they are placed in the lower ligand field, as it has been found experimentally. Therefore, what we see, student, in that the theory is also not complete and also has limitations. No theory, in fact, he is complete in its own way. So there are limitations of this theory, which we said to you that this crystal field theory has limitations. Students has limitations because the assumptions of point charges uh, and anionic ligands should exert the greatest splitting effect, but the halides have been placed lowest. They are found experimentally to be the low fields in the spectrochemical series, and it has no information about the covalent character. So for this, further more theories have been given. Student ligand field theory and molecular orbital theories have been provided. How above this, since they are not required for the course, we are not discussing those theories. Ligand field theory and molecular orbital theory. That's the next level of this. So we're not going into details of that. Okay. The important question is coming in one more topic is there. You have seen what I'm talking is metal carbonyl students. Carbonyls, metal carbonyls student. What we are talking, the complexes of the metal with CO. Carbonyl group is CO students. Now this CO group, what is the CO? If I write, what is the atomic number of carbons is 6,
6,
2, 4, and oxygen is
8.
8, 2, 6. How many? 10 electrons. So if
Yes,
I
sir.
have to write what it looks like, students, C, if I write oxygen 2, 4, 6, 8, and 10. Carbon monoxide. ठीक है?
Yes, sir.
Now the carbon monoxide, there are two donor sites, carbon and oxygen. Carbon and oxygen are the two donor sites in the carbonyl. And if I will write, supposing I have written NiCO4 students, this is a very, very stable, important complex of nickel because it is used for the refining of nickel also. This complex has been used in metallurgy. You will see this complex is used for refining of nickel by a process called Mond's process. That was a very favorite question in the Cbse. That in the metallurgy chapter. Did we do metallurgy with you?
No, sir.
Okay. Now, this out of this carbon and oxygen, what do you think which will be donating its lone pair of electrons, preferably carbon or oxygen? Carbon
Carbon.
or oxygen?
Carbon.
Carbon. Why?
Oxygen is very electronegative. It will not
So,
donate its electrons
so
easily.
it will prefer to keep the electron. So carbon will be preferred a donor. So there is a lone pair of electron. What is carbon is you are saying 1s2, 2s2, 2p. How much is that? 6.
6.
So when you write carbon, then what it has student? ठीक है?
Yes, sir.
2s2p. So the carbon is going to give its lone pair of electron to the nickel. When carbon will give its lone pair of electron, student, carbon gives its lone pair of electron to the metal. ठीक है?
Yes, sir.
This is a sigma bond, student. Sigma bond. Coordinate covalent bond. Coordinate covalent bond. ठीक है?
Okay.
Further interesting thing is that the metal ion, the metal ion student, which to which it is donating, For example, if it is nickel, if nickel is there, nickel is in supposing zero oxidation state. What is the atomic number of nickel, student? Scandium, titanium, chromium, manganese, iron.
Nickel is 28.
28 means this is 4s2 and 3d8.
Yes, sir.
3d8, 3d8, ठीक है?
Yes, sir.
Nickel 0, 0, ठीक है? When CO is there, then what is the oxidation number? There is no charge on the CO. It is neutral. There is no charge. Did I show any charge on the CO? Nothing.
No, sir.
So what is it? 3d8 looks like, student. 1, 2, 3, 4. 1, 2, 3, 4, 5. You are saying 1, 2, 3, 4, 5. But what happens is the hybridization takes place. ठीक है? Hybridization
Okay.
takes place when we shown you the theory of that. Basically, it is how much this lone pair, this 5 and 3, 8 na in the D. But when nickel carbonyl was shown by VBT, what we showed you, this is having tetrahedral shape. Nickel tetracarbonyl. So students, the result of this will be what? You have D, then you have student which orbitals? 1, 2, 3, 4. D, 4s, 4p. ठीक है?
Yes, sir.
So after this there is 4s and 4p. If there are two unpaired electrons, they are going to sp3 hybridization. If it is a strong ligand, it pairs up, then what happens? Then you get dsp2 hybridization. That is a square planar shape. Square planar shape. And what in the valence bond theory, what shape we have given for nickel carbonyl, students? What shape was given for nickel carbonyl? Did we do for NiCO4 case or not? Nickel carbonyl was done or not by us?
For yes, sir.
What was that? It has tetrahedral
Tetrahedral.
geometry
Tetrahedral geometry.
and is diamagnetic. That is what was done by VBT.
Yes, sir.
Okay. And tetrahedral students geometry, but it is diagenetic because there is no unpaired electrons. ठीक है?
Yes, sir.
Then what happened in this? There is no unpaired electron in the case of nickel. And so what is the story here? This is donating. Carbon will, 4CO are coming, 4CO are coming. They will donate their lone pairs of electrons to the vacant hybrid orbitals of the nickel, and they will form sigma bond. And this also has, metal also has, students, its electron pairs, and it can donate it to the, what it can donate to the vacant
Vacant D
p
orbitals.
orbital of the carbon.
Carbon.
Carbon. So that will result in the formation of a pi bond. There is a sigma bond and there is a pi bond. Student, what we are saying, the carbon is donating its lone pair of electron to the vacant orbitals of the central metal. At the same time, the central metal has got electron pairs which it can give. One bond is sigma, other will be pi bond, student. So they can form pi bond. So there are two
Okay.
types of bonding which is happening in this case. Sigma and reverse pi. These two together, they is called synergic bond. So they will
Okay.
make it highly stable. That is the reason these complexes become highly stable, student. So tetracarbonyl nickel is tetrahedral. Pentacarbonyl iron, which is also zero, is trigonal bipyramidal, and hexacarbonyl chromium is octahedral. Here we have given some examples of the carbonyl compounds of nickel, iron, chromium, manganese, students, cobalt. These are the some of the examples of the carbonyl compounds. So metal carbon bond in metal carbonyl possesses both S and P character. Both S and P character. The metal carbon sigma bond is formed. Metal carbon sigma bond is formed by the donation of lone pair of electrons on the carbonyl carbon into vacant orbital of the metal. Vacant orbital of the
Okay.
metal. And metal carbon pi bond is formed by donation of pair of electrons from filled d orbitals into vacant anti-bonding pi star orbital of carbon monoxide. What I am trying to say now, interesting. This is an important question that what is a synergic bonding? What is a question, a student? What we are talking is bonding in metal carbonyls. I said this is an important question for paper. Bonding in metal carbonyls. Many times this question has been asked. Now this is a special type of bond. This bonding, can I put in this way also? This is an example of synergic bonding. Now, what is a synergic bonding that we are able explaining? What I am saying, metal carbon bond in metal carbonyl possesses both sigma and pi character. The metal carbon sigma bond is found here. You see, this is carbon monoxide. Okay?
Yes, sir.
Carbon monoxide, students. And in the carbon monoxide, this is a lone pair of electron which carbon is donating to the vacant orbital of the metal.
Orbital of metal.
This is a sigma bond. What is this? Sigma bond.
Sigma bond.
And there is a vacant pi star orbital of the carbon monoxide. And the metal has got pairs of electrons, lone pairs of electrons, okay, which it will donate it to the vacant pi star orbital of carbon. That is will be a pi bond, student. So there is what we are saying. There is a metal carbon sigma bond, okay, which is formed due to donation of lone pair of electrons, donation of lone pairs of electrons by the carbonyl carbon into vacant
Vacant
orbitals
orbitals
of metal.
metal.
Okay, one bond is this. One bond is this. Second, there is a metal carbon pi bond. How this is formed? Donation of pair of electrons.
Pair of electrons.
Donation of pair of electrons from filled d orbital. You have seen has got pair of electrons in the metal ion from
Yes, sir.
filled d orbitals to metal, which they say metal which is it into vacant to metal vacant anti-bonding pi star orbital. Pi star orbital. Actually, that's a molecular orbital theory. What I told you, valence bond theory, crystal field theory, there is a ligand, there is a molecular orbital theory. In molecular orbital theory, you have learnt in 11th also, we talk of pi and pi star orbitals.
Yes, sir.
So here they are
Bonding and
talking of
anti-bonding.
a theory in which they are saying pi star orbital of carbon monoxide.
Okay.
So this creates a synergic effect. This creates a student synergic effect. They are adding. There are now two types of bond: sigma metal carbon sigma bond, metal carbon pi bond. So they will add up, and it will increase the strength of the bond. What will the synergic effect will be? It will increase the strength of, okay,
Yes, sir.
bond between strength of bond which is formed between metal and CO. The bond is formed between metal and CO is very strong now. Why it is strong? Due to the synergic effect. What is synergic
Synergy.
effect? Metal carbon sigma bond and metal
Metal
carbon pi.
carbon pi bond.
Important point. This is to be written in the paper. This question has been asked.
Okay.
So here is a picture which has been taken from the book. These are the d electrons in the d orbital metal. They are being donated. This is pi star. He has written pi star vacant orbital of the carbon monoxide. And carbon monoxide, carbon is giving its electron pairs to the metal vacant orbitals, which is forming a sigma bond. You know that once a one sigma is bond is formed, other will be a pi bond. There cannot be two sigma bonds
Yes, sir.
because the angle, what is the sigma when it is formed along the axis, the next bond then will be a pi bond. These are the reasons you form very stable carbonyl complexes of the metals. This is an important question for the paper. Very important question. What is synergic bonding and why you see such a large number of CO complexes? The metal is in zero oxidation state. We are not going to use VBD theory for explaining these things. As I said, the only thing we have to discuss here is, but we have only tried to show you, yes, there are electrons in the 3D orbitals of the metal. Those electron pairs, they can donate back. So, and that will be a pi bond, student, in the pi star orbital of the carbon monoxide. And carbon has got electron pair, which it is donating to the vacant orbital of the metal. Interesting. So all this happens, students. So this is a example of synergic bonding, student. And this a question, that's why I am giving more time, because this question has been asked as it is on the screen what we are trying to say. What I'm saying, this is a self-strengthening bond in coordination complex known as synergic bonding. Question will be, what is a synergic bonding? ठीक है?
Yes, sir.
Okay. This was asked many times. Students in the paper. Students could not write correctly. The bond between carbonyl carbon acting as a ligand and a metal is formed by pi acid ligand like CO. These are pi acid ligands are those which have lone pair of electrons to donate to metal atom. Anything which has a double or triple bond, they have pi electrons, na? They are donating. Okay? And metal must have an empty anti-bonding molecular orbital for back bonding with d orbital electrons of the metal. And empty anti-bonding molecular orbital. I'm saying they are using molecular orbital theory. Carbon monoxide has got what? Empty pi star molecular orbital where they can accept the lone pair electron pair from the metal atom. The kind of bonding requires that metal have d electrons. What is the condition then? What is the requirement for synergic bonding? Question number 1. What is synergic bonding? Question 2. What is the condition to form, students, synergic bonding? When it will be formed? It can be formed everywhere. The answer is no. But what is requirement? Metal have d electrons. What is important? Metal have
Metal have d electrons.
d electrons. If a metal does not have d electrons, if it is d0, then what happens? Will it form? The answer is no. Metal have d electrons. ठीक है? Metal have d electrons, and metal is relatively in lower oxidation state. Relatively, we are saying in lower oxidation state. Why? If it is in higher oxidation state, it is already short of electrons. Then why will it donate electron? Tell me. We are saying Mn5 plus. Tell me, if it is Mn5 plus, it is already lost the electrons.
Yes,
Then
sir.
why will it give electrons when it is lost already so many? So metals usually in a relatively low oxidation state, okay, which makes the back donation possible. Which makes back donation possible. And here you are saying they are metal in the zero state. Isn't the zero state has electrons to donate student? If I said uh, +5 and +4, then there is not, then how will they donate electrons? As electrons from the metal fill the anti-bonding orbital of CO, ठीक है, they weaken the carbon oxygen bond compared to free carbon monoxide. The metal carbon bond is strengthened. This is the important point. What is the consequence of synergic bonding, student? What is the consequence of synergic bonding? The metal carbon bond is
Strengthened.
strengthened. Carbon bond strengthened. That is why you see such carbonyl compounds are very stable. Strengthened, students. And that is why you see how many of that I have shown to you. So many are formed. Lowest oxidation state, na? Zero. Zero oxidation state. Chromium,
Yes, sir.
cobalt, manganese. These are all examples of the metal carbonyl bonding, and the oxidation state you have seen here. They are in zero oxidation state. So this is important, and this also ends the bonding of carbonyl compounds. There's only one part left, and some questions to be discussed for the important questions for the exam. Then this topic
Okay.
will be over. After that, I think we are left with biochemistry part,
And solid state.
solid state. Okay, then good night, students. I will see you in the next class.
Okay, thank you, sir.
All right.